Hi, we have another question from Iran Mathematical Olympiad round number 1, year 1997. The question says that what is the size of the largest subset of S? So we have the set S here from 1 to 99. We are looking for the largest subset of S such that no two of its elements are twice the other. Okay, so the question is clear. The first round of Iranian Mathematical Olympiad usually consists of multiple choice questions. For each question, you get approximately 6 minutes. If you answer correct, you get plus 3 points. If you answer wrong, you get minus 1 point. So you must select your answer properly. Maybe spend 5 to 10 minutes try to figure out the answer of this question and then come back and see the solution. The options that we have are 55, 62, 66, and so on. So let me turn on the pointer. Okay, let's look at the solution. We have this set S, which is this one. Obviously, the first thing that we can do is to try to make a subset that none of its elements are twice each other, and we try to maximize the size of this subset. So the first thing that comes into my mind is that if I put numbers from 50 to 99, then none of them can be twice the other, because 50 multiplied 2 is already 100, is larger than the largest element, so none of them will be twice the other. Okay, so I can easily make this subset of S that has 50 elements and none of them is twice the other. But I can improve this one. Of course, I know that I cannot put, for example, 25 in this subset because 25 multiplied 2 is 50. I cannot put 26 and so on. But if I select a number that is less than 25, then maybe I can add it to this subset. Okay, so then I come up with a new idea that maybe I can add from 13 to 24. These numbers can also be put into this subset that we are going to construct. Because 2 times 24 is 48, it's less than any of these elements. And of course, we don't want to select elements that twice of them becomes 24 or becomes the lesser number. So I put here from 13 to 24. Again, none of these elements are twice each other. So this is also good. So we have improved size of the set that we want to create. But actually, we can further improve if we look at this. Okay, we cannot put 12, we cannot put 10, but if we go down, we can actually put 4 and 5 and 6 into this subset because 2 times 6 is 12, is still less than this. And of course, I cannot put 3 because 3 times 2 is 6, so this one is not possible. So I can also consider 4, 5, 6. And if I also add this into the subset, still none of the elements are twice the other. And lastly, I can also consider 1 in this subset. Basically, if I create a subset A that is combination of all of these subsets that I created here, A will be A1, A2, and till A4, then the size of A will be size of this 50 plus 12, size of this plus 3 plus 1, which is 66. So we could already create an example that the size of this subset is 66 and none of the elements are twice each other. We tried by some try and error to create a large subset that fulfills the condition the problems want. But we don't know whether this 66 is the largest number or not. So we have to do something extra to prove this. All right, so let's see that every natural number can be written as 2 power alpha multiply q, which q is an odd number and alpha is equal or larger than 0. So for example, any odd number will be q, and if you have 2 times odd number will be 2 power 1 times q, and so on. Now we are going to categorize all the numbers in set S based on the power of alpha. So for example, if alpha is 0, we are going to have this subset. So all the odd numbers, 1, 3, 5, 7, and so on. If alpha is 1, we will have twice the odd numbers. So 2 times 1, 2, 2 times 3, 6, 2 times 5, 10, 2 times 7, 14, and so on. And then we get to 49. 2 times 49 is 98. And above that, we don't care because it does not belong to this set S. Okay. Now, if alpha is 2, we will have 1 times 4 is 4, 3 times 4 is 12, 5 times 4 is 20, and we continue, we reach to 23, multiply 4 is 92. Okay. Alpha can be 3, so in this case, we have 1 times 8 is 8, 3 times 8, 24, 5 times 8, 40, and then we go further, 7 times 8, 56, 9 times 8, 72, 11 times 8, 88. And these are all the elements that are in the set S. We can increase the power of alpha to 4, so 16. So 1 times 16, 3 times 16 is 48, 5 times 16 is 80, 7 times 16 is already larger than the maximum element of S, so we ignore it. And the next one is 32, so 1 times 32, 32, 3 times 32 is 96, and the last one is power 6, so 2 power 6 is 64, multiply to 1 is 64. Basically, all the elements of S can be categorized in these subsets A1, A2 till A7. Okay. Now, we are going to consider these two subsets. We say that from these two subsets, we cannot select both elements. So if I have one, I can never have two, because otherwise it violates the properties of S. If I have three, I cannot have six, and so on. If I have, for example, 49, I cannot have 98. And for all the other odd numbers. So between these two, the most number of elements that I can select is basically the size of this subset A1, which will be 99 minus 1 divided by 2 plus 1. So this is the maximum number of elements that I can select from these two subsets. From these two subsets, again, I cannot select 4 and 8 together. I cannot select 12 and 24. And then it goes further. For example, I cannot select 44 and 88 and all the other numbers that are listed here. Okay. So between these two subsets, the maximum number of elements that I can select is actually equal to the size of this subset, which will be 92 minus 4 divided by 8 plus 1, because these are increasing by a gap of 8. And same way for the other one, between these two, the maximum number of elements that we can select is 3. If I select 4, then I have to have one of these and one of these together, which basically one of them will be doubled in the other. And for this one, I can select 64. All right, so based on the calculation that we did, the maximum size of the subset A that we can select with the property that none of the elements are twice the other, it will be this size plus this size plus this plus this. This is 50, this one is 12, this is 3, this is 1, so it's 66. So we have already shown that the maximum size of the subset that none of the elements are twice the other is 66. And also we have given an example of a subset that has the size of 66. Basically, the answer is option C, which is 66. All right, so let's see what we have learned. In many problems that you deal with the small numbers, basically you can use try and error method to give examples and try to improve your examples. And if you do everything right, probably what you end up with is the actual solution. But of course, you don't know whether that answer that you found is really the solution or not. So you have to mathematically prove that the solution you found is the right solution. So the second part is applying grouping techniques, show that only part of each group can be in the final solution. And based on that, you can actually define the boundary and the size of the final solution and use this information to answer the question. All right, so this is the end of the video. I hope that you learned something new. See you next time. Bye.